Welcome, everybody. In today's stream, we're going to be talking all about machine learning observability. That way, when we get our models into production, we know what to watch, and we can really be confident that our models are performing in production. And I'm really honored to be joined today by my good friend Avinash. Avinash has been working a long time in this space, originally both as a data scientist and then also thinking about this problem at a few different companies, and importantly, when we work together at Truera. So welcome, Avinash. Thanks for joining.
Oh, thank you, Josh, and welcome everybody. Super glad to be here to talk about ML observability, and looking forward to the chat.
Awesome. So what is ML observability, and why should we care about it?
Observability is a pretty loaded term, actually, which is so it's a very it can mean different things to different people. But when we say ML observability, we specifically are talking about metrics, tracking metrics, or the quality of the model based on machine learning metrics. So, for example, how well is my model doing? How accurate is it when once it's deployed to production as compared to how it was doing while it was training? Is there input data drift? Is there score drift? All these things come under the purview of ML observability.
Awesome. And what are the sorts of problems that can happen if your model starts to drift or it starts to drop in performance once it gets to production?
Yeah, models are like a very finicky entity, I would say, because even though they involve basically their code and built on top of data, they when they are sort of bound by the parameters that they are that they are or the assumptions that are baked into the model are based on whatever the training data set they were trained on. So over time it's natural for those assumptions to become stale, and based on the industry wide events that are happening, the model's performance will start dropping over time. And the some of the issues that you can see, for example, one of the best examples of this was all the pre-COVID and post-COVID airline models, like airline occupation models, and or even credit risk or the credit score models. When users who had higher spends on their credit cards would get much higher scores, right? And then um, suddenly their score started tanking because there were no high spends happening on their airline expenditure was down. So but the models couldn't deal with that automatically. So that's an example of, say, data drifting and the model not being able to handle it by itself. And the other more classic examples of this are like the data pipelines are messed up. So you're sending in data that's not even something that the model understands, and your model can't process that data. So all these kinds of things are possible because once you're in production. There are so many moving parts that things can go wrong. That many places where things can go wrong, and observability is supposed trying to catch them as soon as possible.
Yeah, that makes sense. Yeah, it feels like in a lot of these applications, seconds really matter, right? How fast we can detect these sorts of issues.
No, of
Awesome.
course, yeah. I mean, and a lot of times there's a lot of business dollars riding on these model decisions. So the sooner we catch them, the better.
Awesome. So in today's stream, we're talking about ML observability, but specifically we want to talk about it how it works in Snowflake. So you can give us a bit of a picture about where it fits in the Snowflake stack, and like how we should think about it in that context.
Yeah, happy to. So Snowflake has a pretty vast set of capabilities for doing AML within its platform, and ML observability fits into the Snowflake ML tech stack basically. So Snowflake has different ways of interacting with the ML functionalities that it provides, both on the development side of things and also when you want to operationalize your models. From the development side of things, we have things like ML functions, Snowflake ML APIs for training your models, and but in ML Ops, of which observability is part of, we have the model registry, a feature store which helps managing your features, model registry which is like a model catalog, but also an inference engine for your models, and finally this observability piece which can now be attached to your models that are in production, and which can then help you track metrics for your models.
That's amazing. Maybe it's a good time to jump into it and see it in action.
Yeah, of course, happy to. Let me
Cool.
share my screen. Let me know when you can see my screen, please.
You're good.
Cool. All right. So just to elaborate a bit more on what I was just saying, this is the entire Snowflake ML tech stack where we have the different ways of ways that our users can interact with our ML capabilities, like the Studio, which is our which is basically different ways of creating your models using the inbuilt ML functions. Then there is Snowflake Notebooks, which is the in-house notebooks capabilities for developing your models. And then finally, your external IDEs like your Jupyter Notebooks, Visual Studio, etc., from which you can create a Snowflake session and start using the Snowflake ML capabilities. And underneath this are the different functionalities available. On the development side, we have the ML functions and Snowflake ML APIs. But more interestingly for our conversation today, in ML Ops, we have a new entrant called Observability. And more specifically, we'll be talking about monitoring. How do you monitor a model that's in production? And all of this is powered by the two different compute units that are available within Snowflake, the ML optimized warehouses, and then there is container runtimes, which allows you to create your own container images for running these workloads.
And
A typical
does this work the same way whether we're in the container runtime or we're in the ML optimized warehouse?
You mean the observability?
Yeah, the observability piece.
Yeah, it's agnostic. Yeah, you could be using any of the container units, any of the compute units, and you will be able to use observability. In fact, you could also have models outside Snowflake, running outside Snowflake. As long as you're storing the inferences within Snowflake, you can use observability.
Awesome.
Cool. So this is a typical model lifecycle that you probably are familiar with. Our listeners are familiar with, and are probably using this, where you have data and in some sort of a data lake. You use that data to create your training data sets. You might optionally be using a feature store for managing these features. You train your model using the training data set, and once it's ready, you deploy it to some sort of a deployment, say a model registry. And once you have that, you can start doing inference on this data set. When we say inference, we mean as the model sees production data, it will start generating these predictions, and then these predictions are then stored in some sort of a table on which. So all of this, whatever I described so far, this path already existed within Snowflake. And now we have this new entrant called observability, which allows you to start monitoring the model that's doing these predictions and storing them here. And you can start tracking the metrics on top of that. And whenever you find an issue, you can go back very easily to your environment where you have trained this model and start training the new version of the model, as everything is within Snowflake. So what is observability? I've used that term quite a bit. I spoke about it a little bit in the beginning of the session, but more specifically, when we talk about ML observability within Snowflake, we are talking about a set of built-in tools that allow you to track the quality of your model based on three different metrics. First is activity, second is performance, and third is drift. So you can set up your monitor such that you're tracking its performance to ensure that the predictions are reliable over time. You're tracking its drift so that at scale within the secured and governed environment of Snowflake to ensure that you can actually trust the predictions that you're seeing. You can set up alerts on these metrics based on how sensitive you need the metric to be. You can set up your thresholds, and when the thresholds are breached, you'll get notified through different channels. And finally, we also have metric APIs that you can query this data from and then create your own custom dashboards using that data, or send it to your own centralized dashboards if you need to. All of this comes with out-of-the-box Snowsight UI dashboards, which basically means you can just, once you've set up a monitor, you can just go to our UI and have this dashboard out of the box available to you, and which will start showing you metrics over time. This model, the ML observability does not require you to deploy the model within Snowflake. You can have the model logged to Snowflake model registry, or you could be hosting an external deployment using any of these other services. But as long as you're storing the predictions within Snowflake, the observability piece will work on top of it.
So just on the last side real quick. So I see a bunch of logos here on the left side of the screen. Can you talk a little bit about, just to frame for people, what sorts of models we could be logging and monitoring here?
So the logging, you can log almost anything that you see here, and you can start using them within the model registry. For observability, in the current version, you can only you can monitor classification models, binary classification models, and regression models. Pretty soon we'll have support for multi-class models as well, and then soon, and the ranking, etc. will stuff will follow after that.
Awesome.
So I've spoken a few times, like both the diagrams that I just showed, this monitoring logs is like a key piece that observability requires. Let's take a quick look at what that looks like. It's pretty straightforward, and probably pretty familiar schema for our listeners, where for a given model version, all we expect is a single table which has the ID column, which is to identify individual rows, a timestamp column as the predictions are happening over time in production, the different features that the model is seeing while making the prediction itself, and the actual label whenever it comes. It doesn't have to happen during ingestion. You could just ingest the prediction and the features for now, and then when you get the label in the future, you can just come and add it back in using the ID.
So in the delayed label scenario, how does monitoring work?
Yeah, so in the beginning, when you do the prediction, you'll not be able to do performance at that point because you don't have the label yet. But you can do all the other metrics like activity drift, feature drift, score drift, all those metrics you can set up. And as and when you get the label for the data, you can join it back in using the ID. And there is no, you can go back as far as you want while joining this label. So you could sometimes get the label within a few days, or sometimes it could be within a few months. It doesn't matter. Whenever you get the label, you can just add it in, and then automatically the performance compute. You don't need to do anything else. You just add the label back in, then the dashboard will do all the computations and set it up so that you can go and look at the results.
Amazing. So there's probably a lot we can tell even before we get the actual label in terms of looking at the like feature drift and things like that.
Oh yeah, of course, because you can. We do have some, like for example, if your model is not working at all, your activity counts will start going down. Your traffic will start showing very low numbers. If your feature is drifting, you can. If you have an input data drift, you can immediately see that as well. And then most importantly, and the most common thing that you should definitely be tracking is your score drift. So for example, in your training phase, most of the times your score is between say 0.3 to zero point 0.7, and then suddenly you start seeing a lot of, say you're building a probability score like a classification probability model, and suddenly in production you start seeing a lot of 0.9s, for example. Then your drift would automatically start increasing, for the score drift will start increasing, and then you should be worried, like why is my model suddenly so sure about its classifications when it wasn't during training. So that's like a very easy indication that something has gone wrong.
Got it. Cool.
Cool. So yeah, so you can either pass in this table, or if you already have your bespoke production systems with defined schemas and you don't have the table in this fashion for some reason, we also support views. So you could create a view on top of different Snowflake tables and then pass in that view to observability, and that will still work. Cool. I've been talking for a while. Lots of slides. Let's jump into the demo.
Yeah, demo's always a fun part.
Yeah. Cool. So let me just go back to the top. I'm just gonna run all so that I can keep talking while the notebook is doing its thing. Okay. So for my demo today, I'm using a Snowflake notebook. This is what it looks like for the people who are seeing it for the first time. Very simple. It has a lot of convenience tools. It's very convenient to use a notebook within Snowflake. With this, I can set up my own warehouses. I can set up whatever compute I want all of this to run on. I can set up my own packages, etc. So it's very convenient instead of using my own local local IDE. I prefer using a Snowflake notebook. But for this example, I'll be taking a use case of a financial institution that is trying to figure out why are their customers churning out. For that, we'll be building a classification model, which uses a bunch of these features such as credit score, geography, how many products do they have, what's their bank balance, etc. The example is not that important, but and a lot of this is not related to observability at all, but it's helpful to because observability, as by its nature, comes at the end once you've deployed a model. So I'm just quickly going through a mock flow of how building a model, deploying it within Snowflake, and then setting up observability on it looks like. So here's a quick peek at the training data set, the different features we were just talking about, a quick ID column, and then we also have the label here which says exited, which is whether the customer has exited the bank or not. I'll be using this for building my model. I'm setting up a quick pre-processing pipeline where I'm using an ordinal encoder for converting all my categorical features to zeros and ones, and I'm using min-max scaler for normalizing all my numerical features. And once I have that done, I've created a pipeline object. I'm going to train my model, which is going to be an XGBoost classifier, which will basically at the end of it classify every time it gets an input for a user or a customer. It will classify whether this person is going to leave is churn out of the bank or not. Now looks like I have the model ready. So we're gonna next step would be to log this model to model registry. For that, I'll be creating a registry object and using the registry's log model function to log this model with a model version v1. And once I've done that, once you deploy a model to model registry, it's inference ready. What that means is you can immediately start using it for generating predictions by using model predict function. Sorry about that notification. I'll talk about that notification in a second. But uh, so what what we have done so far is train the model, log the model to model registry, and I've started an inference pipeline which is feeding it data to mimic a production scenario. So far, so good. None of this was on ML observability. Whatever I did was just initial setup. Typically, this was something that you would do as part of your deployment pipeline. Now let's talk about how to set up a monitor on this model. So enabling monitoring actually is just one single command, either a SQL command or a Python command. In this example, I'm showing you a SQL command, but as many things in Snowflake, we have both ways of doing it. Either you can use the SQL API or the Python API. And the way you would set up a monitor is just by using this one command, which says create model monitor, give it a quick name, and pass in a few parameters such as the model, the version, and the most important parameter here is the source parameter, which is the table that we were just talking about here in the slides. This table, you need to give us the name of that table, which is either the table or the view, and just pass in the name of that table where you're storing the inferences and the features, and just describe that table a little bit for us. Tell us the different column names, which is the because the column name is up to the user. Just tell us which one is the timestamp column, which one is the prediction column, which one is the actual column, and which one is the ID column. And we assume the rest of them are the feature columns. So these are the most critical parameters here. There's one other optional parameter, but super important, which is baseline. Baseline is nothing but another table that you pass to us, typically the training data set, but of course you could use any data set, any table as your baseline. This baseline is what we will use for all our drift computations. So baseline, that once you give us the baseline, we'll snapshot it, fix it, and then over time, as and when new data comes in, we'll keep computing drift using this using this baseline. Cool. So that's pretty much it. This is one SQL command with some parameters that you need to pass in. You run that, and then after that, you don't have to do anything. As and when your inference pipeline keeps running, wherever your model is deployed, this table should ideally keep getting appended to the source table, and the monitoring metrics will keep getting computed automatically. Let's take a quick look at what the UI looks like after this. So for that, I will go to my AI/ML section in my Snowflake UI. I'll go to the models, and I will see the demo. This is the model that I just created. I can just click into that and click into my monitor. And here you can see already the metrics are computed, and I can track the metrics over time. You can configure these metrics as per your use case, depending on what is important to you. You can use the settings to configure these panels. You can have, for example, the three kinds of metrics available today. First is the activity metrics, like how many predictions are happening, how many of those predictions you have already ingested actual counts for. Actuals are nothing but the ground truth labels. How many different performance metrics. In this case, it's a classification model, so that's why you're seeing classification metrics, classification model metrics. Or you can, if this was a regression model, this would flip to regression metrics. And then you can also set up different drift metrics, both for the model score or for particular features that you want to track drift for. So you can add it's very easy to add a new one. So you can just add a new feature or a new panel, and it automatically shows up, and the metrics are already computed. So one of the USPs of doing this within Snowflake is that the metric computation is extremely efficient and happens very quickly and without having to get new access, or it's all of this is happening within Snowflake, so it's not leaving the Snowflake's boundary. Now this is the UI. You can also get this data by using a metric API. So if you, for example, want to create your own dashboards, like a Streamlit dashboard, or have a central dashboard that you want to send data to, we also provide different metrics for you to run, different functions that you can use, such as the model monitor performance metric that you can use for getting this data as well in a function call. You can also set up alerts on these metrics. We can using the Snowflake's alerts and notification system, where you can just use create alert, give it a quick name, pass in the condition that you want to alert on, and then do different things that you want to do when this alert threshold criteria is met. For example, here I'm saying that when the metric value is greater than 0.05, so if that I'm trying to find the drift for this monitor for the prediction. So basically, if the score drift goes above 0.05, then this clause would get triggered. And here I'm sending my two notifications, one over email and on Slack, which is what you just heard during the call before. I've just got an email notification a couple of minutes back. And I'm also setting up a Snowflake table in which I'm putting in all the data that the model was not doing well on, so that I have this nice little data set that I can start debugging.
So here you're sending some alerts over email and Slack. What if I want to do something a little more complicated, like maybe retraining the model on this like new data? Can I do that here?
Of course, yeah. So this is ultimately again a SQL command. So you can do whatever you want in this then clause. So this is literally world is your oyster here. You can use the UDFs or tasks. You can define your UDFs and call them here, or you can call tasks, streams, etc. So totally up to you. You can run retraining pipelines. You can run different downstream actions if you want to move data based on what has happened here. All of that is possible.
Awesome.
Cool. So you can so that's so far we have seen how the UI looks like. What can you do while when you what can you do when you set up the monitor, when you you can see the UI and see the dashboard, and then you can also get the data using metrics. Now that you know that this model had sent an alert, so we can now I'm not going to walk you through the demo, but I'm going to build a second version of the model and deploy it here, so that we can which hopefully has fixed the issue that we just saw, we just got notified on. And I'm exactly going to do the same steps that I just did before, where I created a model version, I trained a new model version, logged that to model registry, and created a monitor doing the exact same things. And now you can see that there is a second monitor available for me in the UI, which was not there before. So you have two model versions and two monitors. So we have a one-to-one mapping between a monitor and a model version. So you can now go into the second model version and get the exact same view as before. You can then also do an A/B test live, where you can compare both the model versions for the same given time period and keep sending it data and see if the model version V2 is doing better than model version V1 or not, which we can clearly see here for this time period, at least between Feb and March. The newer version of the model is much better. So this way you can live simulate an A/B test and then decide whether the V2 is the better version of the model and promote that to production. Finally, you can also quickly get all the metadata about your monitor. Like for example, when was it last updated? What's the refresh interval, which is nothing but how often does this monitor look for new data, and aggregation window, which is what does each point represent in this graph. Where, for example, if it says 1 day here, all the metrics are computed for 1 day. So whatever number you're seeing here is for 1 day. So it's saying 294 predictions were done on March 1st, and on March 2nd, 298 predictions were done, etc. So similarly for these, the F1 score for March 2nd was 0.97 and 0.98 on Feb 28th, etc. This can be changed as per while you're creating the monitor, or once you this is one of the parameters actually you pass in while creating the monitor.
Is it possible to alter the refresh interval or aggregation window after you've created the monitor?
Yes, you can use the alter monitor command to change them.
Awesome.
And the UI actually is intelligent enough to aggregate this automatically. So for example, if I'm doing last 28 days, it shows you daily. If you go to 12 months, I don't have enough data here, so the graph is going to look weird, but it automatically starts doing it for a week. So you see Jan 27 to Feb 10. So yeah, there's some sort of intelligence built into this.
Very cool. And when we get new data in, do we have to like refresh the page or anything, or it's just like automatically going to show up here?
Yeah, I mean, if you have, it's automatic. You don't have to do anything. You might have to refresh the UI if the UI is already up and you've not gone away from for a while. But you don't have to do anything else. You just the data just keeps coming in.
Awesome.
Cool.
Can you explain like a little bit about the different metrics we see here? So you explain the activity counts. Maybe a little bit more about like the performance metrics and like any drift metrics we might want to know about.
Yeah, of course. Thanks. So the activity metrics are pretty straightforward. They're literally telling you how many predictions you are getting, how many predictions are you doing based on the aggregation window. So in this case, it's 1 day. So it's basically telling you how many predictions per day are you doing. And actuals is basically telling you how many of those predictions have the ground truth label. So ideally, this would be at a lag where you don't have actuals for the latest data, but you'll have actuals for some data in the past. So it's good to know how much data do you have actuals on, because the performance metrics require both of them, right? So if you have very little actuals, maybe you should just wait for trust before you trust your performance metrics. And then performance metrics these are pretty classic ML metrics for classification models. The AUC is grayed out because I have not put in the score, but if you put in the score, this would also be available. I have directly put the zeros and ones, the decisions of the classification model, which is why these metrics are available to you. But if you ingest the score, you will also get this metric. And then finally, the different drift metrics that you can do are you can do the drift on either the prediction score, which we call the score drift, or you can do it on the label drift. So you sometimes your labels might also drift, so which indicates that you just don't have very different kinds of distribution of the data for the labels in production compared to your baseline. And then finally, you can do feature drift, where you can set up the different important features that are available to you. You can pick which are your important features, and you can track drift on them as well. And this is super important because a lot of times, as a business use case, the data scientists, based on the businesses that they are building these models for, will know that, hey, these are my important features, and if these drift, I cannot trust the model decision anymore. So it's super important to set all these kinds of different drift metrics. But drift is something that you can do immediately as soon as the model goes to production. You don't have to wait for the actuals to come by. So this is your pretty much first line of defense, I would say, when the model if the model starts misbehaving.
Awesome. That makes a ton of sense. Rita, do we have any questions in the chat? Cool. I think we're just about at time. Is there anything else you think you want to share with the audience before we wrap up?
No, I mean, I think the ML observability is generally available as of last week. So all of you, whoever has a Snowflake account, can go and start using this functionality. We'll be dropping in the Quickstart links and making them available. So whatever demo I've just done is using the Quickstart. So you should be able to pretty much replicate whatever I have done using our Quickstart. And yeah, I'm super excited to get some usage going on this feature, and hopefully people like this feature and gives us a ton of feedback so that we can keep improving it.
Yeah, that's awesome. And I think, as Avinash mentioned earlier, it's just like one SQL command to add the observability, so it should be really easy for folks to get started. And I just got word that all the links are now dropped in the comment section, so you can go straight there and smash the quick start button. Well, thank you so much for everybody for joining us, and thanks to Avinash for telling us all about observability.
Thank you, my pleasure.